Hello, algebra students. Mr. Lawrence here. We're going to start chapter 8, and it's a good thing. This is the second semester. My honors classes, you are ahead of the game. My regular algebra classes will be starting it right at the start of the second semester, so good deal. All right, we're going to do laws of multiplying and dividing exponents, which are real simple. In fact, you can probably tell me what they are just by seeing a few examples. But before we do that, we have to learn the words monomial, binomial, trinomial, and polynomial. Now, just for the record, a polynomial is not when you forget to feed your parrot. Okay? Get it? Polynomial. Ha ha ha. Sorry. Okay. Anyway, mono means one. Okay. Bi means two. Tri means three. Right? Just picture Paul on his little tricycle that he got for Christmas riding around. And then poly means many. Okay, poly means many. So when there's more than three, we say poly. All right, and all it means is terms, how many terms it has. So look at these terms I have written over here. I've got a 3x, a 5x squared plus 2x plus 4. Oop, I didn't want that to happen. Let me regroup those all together. I've got a 4x cubed plus 2x and the one in Poiple down here. Well, this red one here only has one term. That's a monomial. Okay. Um, by the way, a plain old number by itself is not a monomial. Like for example, 5. That's called a constant because it doesn't vary. It stays the same. All right. A monomial. Another example of a monomial might be like 15x to the 7th power. That's another monomial. It's just one term. Okay, because it's all attached by multiplication. When you get attached by addition or subtraction, then it becomes multiple terms. Like this one here has 1, 2, 3 monomials. Well, 2 monomials and a constant, I should say. And that is a trinomial, right? Okay. This one has 2 terms. That's a binomial. And there is one with 4 terms, and that's a polynomial. Okay. Another example of a binomial could be, 5x squared minus 1. It's got 2 terms, a monomial and a constant. Another trinomial could be like 10x cubed plus 2x squared minus x. 3 terms. 1, 2, 3. 3 monomials put together. All right, that should be pretty basic, but you have to become familiar with the terms. And of course, by now I already expect you to be familiar with these terms, the terms of coefficient and of course exponent, right? Exponent. I already expect you to know those. I've been using coefficient quite a bit lately. So coefficient of this term is 15, right? And the exponent is 7. All right, so let's move on to how we multiply monomials. Now, can you think of a way to say, let's say we have this problem here. Say we have 5 times 5 times 5. Now, I know with just a little bit of quick figuring, you can tell me it's 125. But can you tell me a different way to say that without saying 125? I mean, a shortcut way of saying 5 times 5 times 5 without saying the actual answer. Well, wouldn't it be 5 to the 3rd power? And let me ask you this. How many 5s are here? 1, the exponent of 1. And there's a 1 there and a 1 there. Now look at that. 1, 2, 3, and we got 3. What do you suppose 5 squared times 5 cubed would be? Well, wouldn't this be 2 5s being multiplied? And wouldn't this be 3 5s being multiplied? And so how many 5s are being multiplied together? 1, 2, 3, 4, 5. Well, 5. So that would be the same as 5 to the 5th power. And look at that. 2 plus 3 equals 5. So when I have like bases, when the bases are like, then I add the exponents. When I have like bases, when multiplying monomials. If I have like bases, I add the exponents. See, there's my base, there's my base. They're like, so I add my exponents of 2 and 3 to get a base of 5 and an exponent of 5. Okay, so let's see how that works with monomials. Now these are so simple. I'm going to do 2 times 3 and I'm going to get 6. X times x. Those who are thinking that it's x are thinking that 3 times 3 must be 3. No, I got x to the first times x to the first. That's x to the second power. There you go. The bases are x. I added the exponents. Number 12. I'm going to do 12 times 3 and get 36. I've got an x for my base. X for my base. 2 and 4 is 6. X to the sixth. All right, this part here is x times x. This part here is x times x times x times x. You can see there are 1, 2, 3, 4, 5, 6 x's being multiplied. Instead of saying x times x times x times x times x times x, I say x to the sixth, and there we go. Okay, it works the same way in distribution. I'm just going to multiply here, and then I'm going to multiply there. So 5 times 3 is 15. X times x cubed is x to the fourth. 5 times negative 2 is negative 10. X times x is x squared. And there you go. You may want to repeat that to yourselves a few times because it's kind of a mistake with new algebra students. X times x equals x squared. 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 Do whatever it takes for you to be successful. All right. Now, if you know how to multiply monomials, dividing is pretty simple too. So let me do this here. Shoop. Give myself a little more room. Let's suppose I had a problem like this. Um, I had, let me see, 5 to the third divided by 5 to the second. Well, I could rewrite this as a fraction, and I could also rewrite 5 to the third as 5 times 5 times 5. Then I could write 5 squared as 5 times 5, right? And if I look only right here, those two cancel out, don't they? And those two cancel out, don't they? Leaving me 5 to the first, or simply just 5. So what do you think the rule is for dividing like bases? When dividing monomials with like bases, I subtract the exponents. Yeah, because 3 minus 2 is 1. And the simplest answer, of course, is just plain old 5. So let's try that out down here. Let's go 16 divided by 8. Well, that's 2. X to the fourth divided by x squared is going to be x squared because 4 minus 2 is 2. If it's written this way, I simplify. 20 divided by 2 is 2. Excuse me, 20 divided by 10 is 2. And then we have x to the fifth over x to the fourth. Now, if you really need to see it, that's the same as this. There's my x to the fifth. They're all being multiplied to each other. And here's x to the fourth. And they cancel, 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 cancel again. And so I'm left with 2x. Or 5 minus 4 is 1. Okay, the best answer is 2x. But just to emphasize that, the 5 minus the 4. Okay, last one. And then we'll let you go for today. Okay, I'm going to have 8 over 40. Well, 8 over 40 is the same as 8 over 8 times 5, isn't it? 5 times 5 is 40. Those cancel. I'm going to get 1/5, right? And x to the 10th divided by x cubed is going to be x to the 7th. X to the 3rd divided by y to the 6th is going to be y to the negative 3rd, right? Because I do y to the 3rd divided by y to the 6th. Well, 3 minus 6 is -3. And we're going to talk more about negative exponents in another lesson, but I just wanted to introduce that could happen for you. All right, that's going to be it for today. Mr. Lawrence signing off. Good night, everybody.